The purpose of the nitrate test is to tell you whether you have bacteria that are capable of reducing nitrate. And so if nitrate is indeed reduced, what occurs is that the nitrate is converted to nitrite. Some bacteria can reduce nitrite even further to produce these things, ammonia and nitrogen gas. So basically what we're saying here is that if you have bacteria that are capable of reducing nitrate, any of this stuff can be produced, right? So if any of this stuff is in your tube after the incubation, then that indicates that the nitrate was reduced. So kind of the trick then to figuring out whether the nitrate was in fact reduced is to look for any of these substances in the test tube after the incubation period. And so how do you do that? How do you tell whether any of this stuff was produced? First of all, we'll tell you how to see if nitrites are in the test tube. Right, so how do we test for the presence of nitrites? Well, it turns out that we have stuff that are basically nitrite detectors. And so here's what we're talking about. If you run a nitrate test on a bacterium, in other words, if you're interested in finding out if a bacterium is capable of reducing nitrate, what you do is that you inoculate the bacterium into a nitrate broth, right, which has nitrates in it. After you incubate this tube, if the bacteria that you put into that tube were able to reduce the nitrates to form nitrites, the way you'd be able to visualize that is that after this incubation period, you add, again, stuff that basically serves as nitrite detectors. And the chemicals that serve as nitrite detectors are sulfonilic acid and alpha-naphthylamine. So you're going to be asked to add these chemicals to your tube, to your nitrate tube, after the incubation period. And again, we said that these things, they function as nitrite detectors. And the reason why I consider them to be nitrite detectors is if they are in a tube together with nitrites, then it ends up forming a red color. Right? So if you add the sulfonilic acid and the alpha-naphthylamine and you see a red color, that means that there are nitrites in the tube. And if there are nitrites, NO2, in the tube, then it indicates that the nitrate, NO3, that was there to begin with, was reduced by the bacteria. And so this is a positive result. This tells you that your bacteria are indeed able to reduce nitrates. What if you see this happen? Right, so what if you inoculate the nitrate broth with bacteria, you incubate it, afterwards you add those nitrite detectors, the sulfonilic acid and the alpha-naphthylamine, and you see no red color. Right, so what would that indicate? Well, again, all of these chemicals here, what they do is that they serve as nitrite detectors. So if they don't produce a red color, all it tells you is that there's no nitrite in that tube. Right? And so if there's no nitrites in this tube, that could actually be due to one of two reasons. Right? So there could be no nitrites in the tube either because, one, the bacteria were not able to reduce the nitrates to begin with, or another reason why there might not be any nitrites in the tube is that the bacteria reduce the nitrates, but all the way down to ammonia and nitrogen gas. Right? So what we're saying is that there's two possible, two reasons why there's no nitrites in the tube. And so to figure out which one of those two reasons caused there to be a lack of nitrites in the tube, if you see no red color after adding the sulfonilic acid and the alpha-naphthylamine, you have to do one additional step to let you know which of these two possibilities occurred. So here's what we mean by that. So again, if you inoculate a nitrate tube, and then after that incubation period, you add the sulfonilic acid and alpha-naphthylamine, you see no red color. That could be because either one, the bacteria weren't able to reduce the nitrates in the tube, right? So everything in the tube is still in the form of nitrate. Or it could be because the bacteria that you inoculated the tube with reduce the nitrates all the way down to ammonia and nitrogen gas. Right? So they kind of bypass the nitrite producing stage. So how do you know which one of these two things occurred then? Well, what you do is you'll be asked to add some chemicals that function in reducing any remaining nitrates in the tube. So those chemicals are this. So you're going to be asked to add zinc and hydrochloric acid if you see no initial red color. And again, what these chemicals do is that they force any remaining nitrates in the tube to be reduced to form nitrites. Right? And so because in this tube, when those nitrites are produced, you already previously added the sulfonylic acid and alpha-naphthylamine that serve as nitrite detectors. At this point, you should see a red color, right? Because anytime nitrites are in the presence of these two things here, it'll produce that red color. So kind of the bottom line here is that if you see a red color only after adding the zinc and the hydrochloric acid, that tells you that the bacteria you put in that tube are not able to reduce the nitrates. And the proof is that you only see the red after you add the zinc and the hydrochloric acid. So that tells you that it's not the bacteria that's reduced the nitrates. It's the stuff that you added, the zinc and the HCl, that reduced the nitrates. If, on the other hand, you add the zinc and the hydrochloric acid and you see no red color even at that point, then what that tells you is that, well, there's no more nitrates in the tube, because there is nothing for the zinc and HCl to reduce. There's no nitrites in the tube, right? And you figured that out because when you added the sulfonylic acid and alpha-naphthylamine, there was no red. So what that leaves then is that, well, if you see no red even after adding the zinc and the HCl, that indicates that the bacteria that you put in this tube reduced the nitrate all the way down to ammonia and nitrogen gas. Right? So the bottom line kind of take-home point for this tube is that if you add the sulfonylic acid, alpha-naphthylamine, see no red, then you add the zinc, HCl, you see no red. That tells you that the bacteria that you put into that tube are capable of reducing the nitrate, and they reduce it all the way down to ammonia and nitrogen gas. That's why it remained clear. So again, kind of the explanation as far as why you add all this stuff during a nitrate test.